Hey, Nathan here from PH Studios, and welcome back to another Tower Defense Engine tutorial. In this tutorial, we're going to cover the Monster Class Part 2, where we will actually fill in the methods that we created in Part 1. So last tutorial, we talked about the Bullet Class and did Part 2 of that, and we're going to do Part 2 of all the Part 1s we did before, and we're going to fill in all the method bodies. So first things up is the constructor for the monster. So let's go ahead and get started with that. I'm just going to go ahead and format that really quick. Okay, so the constructor is going to be used just to set our local variables and properties to where we want them to be. So what a monster is going to do is we are going to put it on the spawn location, the spawn tile. Then it has a set path to the destination, our house, our castle, whatever. And that gives us a list of nodes or tiles that the monster can travel to. So every time a monster is on a tile, it checks to see the next tile, and then it moves to the next tile. Now that can cause a problem if we do this incorrectly, like we want to move it to a dedicated position. That'll cause problems if we have a set speed and it goes above that position, and then we get kind of a glitch effect where it will always move back and forth in one tile. So you can decrease the speed when it reaches that amount if the distance is less than speed. You can just move that distance left, or you can do a distance calculation and keep track of your distance. And that's the way that we're going to do in this one, and we did that by creating the properties for distance to travel and distance traveled. So we need to set those properties. Distance to travel is float.min value. We want to set it to the opposite maximum. So distance to travel should be a very large amount relatively. So we need to set it to a very small amount initially. So the minimum value of a float. Distance traveled is the opposite again, so float.max value. Distance traveled should initially be 0 every time we reach a set tile. Okay, so now for the update method. Above the base.update, let's start coding. We need to check for damage over time. So if we have .health is greater than 0, so we have some value for .health, and the .timer is greater than 0. So we can, those two values are set whenever we want to perform damage over time. And again, remember, the future update will have actual abilities and statistics to deal with. But for now, we have hard-coded damage over time and area of effect. So if those two are true, if we have .health and we have a .timer, then we need to update we pass a game time, and if .timer is greater than .time, now we set them to 0. Delta health is equal to 0.0f. .health is equal to 0. .time is equal to 0. .timer is equal to 0. So we're just setting everything to 0 because we are finished with the damage over time feature. And you don't really need the .0f here, so you can just take that out. Okay, so that's the damage over time. Now what we need to do is handle the hit. whenever a monster gets hit, it will show a cool effect that shows you the damage that it was dealt, and it will move up from the monster. So that's being handled by a hit timer. So if hit timer is greater than 0, we still want to display that hit value. So hit timer, we need to subtract our elapsed game time. We need to cast it as a float. Game time dot elapsed, game time dot total seconds. And again, we're going to multiply by the session dot singleton dot speed, our current speed of our game. So that will subtract the hit timer. Hit display dot update. Game time. And then we set if hit timer is less than or equal to 0, which means we have reached our end of our timer. We just need to set hit display is equal to 0, is equal to null. Okay, so whenever the map starts or a wave starts, we will delay a monster by a certain amount of time. Every monster will have its own delay, because as you can see in some of the waves, they would have monsters spawn like every 3 seconds, and you'll get a nice long string of monsters that are evenly spaced out, and that's because each monster has its own delay. So now we need to calculate if it's still in a delay state. So if delay is greater than 0, that's the delay timer. So if delay is greater than 0, we need to subtract our elapsed game time, just like we did above. And you can copy that. You can just copy that line we created above, and then paste it down there. So that's the delay state. Now we have an else. It's no longer in delay state. And since we're in an active state, we are going to use the pathfinding class we created a couple of videos ago and actually use the shortest path that the A-star algorithm generates for us. So we're going to create a pathfinding object instance of our shortest path. And we get that from the wave.path.shortest-path. Now that will give us the shortest path from our spawn location to our destination location. If we have reached our destination location, the monster needs to die and we need to remove it from the wave. If path index, we store the index that the tile that we are currently standing on, we save that index in the shortest path so that way we can continue forward and we know where we are. So if the path index is equal to the shortest path dot path dot count and distance traveled is greater than distance to travel, we want to die, which will just set the monster to be a inactive state, and since it's a derivative of gameplay object, we have access to the die method. So we die, and then we remove it from the wave. So we call wave.remove. We pass it this. Else, if the monster is not at the last tile, the last node in the path, we need to move that monster to the next node in the path if it has reached its destination threshold. If it is not, we need to just increase our standard position by increasing velocity and all that stuff. Okay, so let me go ahead and code that and I'll discuss that in more detail. So let's get a let's get an ith item in the path. So we have a path index. We want to get the ith item, which is just the next node in the path. So we just increase that by 1, and we store that in I. So we get the next node in the path, and if distance traveled is greater than distance to travel, that means we have reached our destination and we need to move to the next node in the path. If I is less than shortest path dot path dot count. So we have more nodes in our path that we can travel to. Let's call new node in path shortest path dot path sub I, closing parentheses and semicolon. So we call the new node in path method, which we have not created the code for it yet, but we coded the headers. So we just call the new node in path, and that will get us the monster all set up to move to the next node in the path. Else, if we have no more nodes left in the path, we need to move to the end node, our destination node. New node in path, wave.path.end. Okay, so if the distance traveled is less than the distance to travel, which means we still have to move to the node we are currently looking at. Let's just increment distance traveled plus equals speed times, let's float this, float game time dot elapsed game time dot total seconds times session dot singleton dot speed. Okay, so that is it for the update method. The base is what takes care of the updating the position and velocity and all that, matrices and bounding rectangles and all that stuff. So that's why we brought in the gameplay object. Alright, next up is this update dot method. So let's go ahead and code that. So the update dot method is going to be called when we want to update the damage over time ability. So let's get the amount of delta seconds, so the amount of seconds that has changed, so the elapsed game time. Total seconds times the session.singleton.speed. Okay, so anytime we want to gain access to the game time and we want that part of the game to be affected by our user interface speed increase or decrease, we want to use this session.singleton.speed here. Alright, so now we need to increment the dot timer and dot health. Dot timer plus equals delta seconds. Okay, so now we need to increase the delta health plus equals dot health times delta seconds. The whole idea behind the damage over time is that you take a certain amount of damage over a certain amount of time. So we have the dot health, so let's say 10 health over 10 seconds, but you want to increase the delta health by the elapsed game time and the total dot health. So we basically are creating a buffer. We have a delta health, and we know if we have 10 health that we're going to take over 10 seconds, we know we're going to take one health point per second. But we also know that a game runs much faster than every second. So we need to store up that buffer until it reaches 1. This is a float value. The delta health is a float value. So we store the buffer. We keep on incrementing this delta health until it reaches 1 or higher. 1.0 or higher. When it reaches that point, then we take damage of that 1, and then we repeat the process. We subtract the value, and we increase the delta health again until it reaches 1.0 or higher, and then we take that 1.0 damage. And then we keep on doing that until the damage over time ability is finished. So at the moment, our monster's main health is an integer. We need to get from a float value that is being generated through an algorithm of damage over time and an ability, and we need to move that to, in order to subtract that, we have to convert it to an integer. 0.9 to an integer is just going to be 0, so we can't really subtract 0.9 as an integer from our health because it will just be subtracting 0. So that's why we need to wait until delta health is 1.0 or higher in order to take our damage, take our health away. So that is why we multiply delta health by delta seconds. Okay. So we need to convert our delta health to an integer. Int damage is equal to convert it as an integer, so we cast delta health, and then if damage is greater than 0, that means it's 1.0 or above, which is not really 0.0 because we converted it as an integer. So it's 1 or above. Then we take the damage of just 1. Health minus equals damage. We need to do the same thing for delta health, though. Delta health is equal to delta health minus damage. So we subtract that 1 so we can work on the buffer again. If health is less than or equal to 0, it means we are dead. Wave.remove this. Die, just like the method up top here. We need to remove it from the wave and call die. Now we have a session.singleton.add money. Whenever a monster dies, we add money to our session. Now, if it's a boss, we get double the money. If it's not, we get the normal amount. So is boss. We have a property here to say if it's a boss or not. Now I'm using the question mark colon operator. If you don't know about that, it's just a simple shorthand way of doing an if and else. Wave.money per kill times wave.boss money scalar. Now you can make it to where a boss can give you 4 times the amount of money or 10 times the amount of money. It's completely up to the programmer. If it's not a boss, we just call wave.money per kill. Okay, so the question mark colon is just a very short way of saying if and else. If this is true, it performs the logic right after the question mark. If it is false, it performs the logic right after the colon. So if it is a boss, we multiply the money per kill by the boss money scalar. If it is not a boss, we just add our standard money per kill. Okay, so now the monster is tied to a die event. So if die event does not equal to null, that means if we have listeners for this event, we need to call this event. So die event, this, comma, event args dot empty, semicolon at the end. Okay, so we have that wrapped in a nice if block, and let's create an else block. So if we still have health left, we need to set hit timer is equal to 0.2f. It's hard-coded for now. I'll probably change it to a variable later. Hit display is equal to new text damage.toString, comma, new vector2, opening parentheses, and we want to get it at the monster's location on the right top side, and we'll get that based on the rectangle. Rectangle.right. Let's add some padding or some more so it's over to the right a little bit more, comma, rectangle.top. Closing parentheses, comma, new vector2 velocity.x, comma, minus speed. Okay, so what we're doing here is we have some health left. Our monster has some health left. Now when you hit a monster, it's going to display the amount of damage that monster took as you hit it. And it's going to display that number to the right of the monster with a little bit more extra value, so a little bit more than just to the right of it. That's why we have the +3 here. And at the top of the monster, so at the right top, and then it's going to move up. And that's going to happen for 0.2 seconds. Alright, that's it for this video. There will be a part 3 in the next video, and we'll finish the monster class. It's just been getting a little bit long, and I need to run out and do something, and I'll just separate this into 2-part tutorials. So, next tutorial will be monster part 3, and then we'll continue on with the tower, wave info, and map region classes. So, I hope to see you next time. Hey, Nathan here from PH Studios, and welcome back to another Tower Defense Engine tutorial. And in this tutorial, we're going to finish the monster class. Last tutorial, we focused on a few methods up top. We got those all coded and ready to go, and I discussed them in pretty good detail. Now we're going to finish the monster class by finishing up the last 5 methods. So let's get started with apply dot. So we have an update dot method we just finished last tutorial, and now we have to have an apply dot method where we will actually apply the damage over time. So the apply dot method brings in the damage and time, and we need to store those into our fields up top and reset some of our delta fields. So if dot health is equal to 0 and dot time is equal to 0, what this does is if we do not currently have a damage over time ability associated with our monster, if that monster does not currently have a dot effect added to it, then we need to apply a dot effect to it. Delta health is equal to 0. Dot health is equal to damage. Dot time is equal to time. Dot timer is equal to 0. Alright, so that was a pretty easy thing to add. Now we have a new node in path method. And in this method, we're going to look at the next path and move towards it. We need to rotate the monster towards that path, that node, and then we need to set our velocity to move to that node. So we need to increase our path index. Now we need to get the tile position of the tile we want to move to. Wave.map.toWorld coordinates t. That will convert our tile position to the world coordinates. And we pass the tile we want to move to the method. Vector2 new velocity is equal to new vector2 opening parentheses tile position dot x minus position dot x comma tile position dot y minus position dot y. This is a standard vector, a two-dimensional vector operation we've been using in the past. It grabs a new velocity between those two vectors. Distance to travel is equal to new velocity, the actual object new velocity, dot length. Distance traveled is equal to 0. Every time we change the node, change a destination node, we need to reset our distance to travel and our distance traveled. Now we need to normalize our new velocity vector. Why do we need to normalize it? The current vector up here, when we created the vector, it has a length of the distance to travel, which is why we set it to the length. We need to normalize it and then multiply it by the speed, because that's the maximum speed our monster can travel. And a better way to discuss this is the way that it's set right now, right where I've highlighted it. One game loop, we will be on the old tile. The very next game loop, so 1/60th of a second, we will immediately jump to the new tile. So that's why we need to normalize it and then multiply it by the speed. Velocity. We need to set it as the main velocity. Vector2 dot to multiply. New velocity, comma speed. Okay, so the last thing we need to do is we need to rotate our object. Rotation is equal to float math.atan2 opening parentheses velocity dot y comma velocity dot x. Alright, just a few more methods left, and the next one on the list is add to wave. And this is going to be a very complex method. You've never seen any code as complex as this. That's all that method is. It's a very simple method. Alright, next one on the list is hit. I don't think I need to discuss what this line does here. Alright, so the hit method is going to be called whenever the monster is hit. We need to start the audio, our hit audio, and we need to decrease its health, and if it has a less than 0 health, less than or equal to 0 health, we need to remove it from the wave called die, and add our money again, just like we did with the damage over time. If it's not, we need to display a hit timer, just like damage over time. Okay, so first thing up is starting the audio. So audio manager dot singleton dot play sound, opening parentheses, hit Q name, closing parentheses, and semicolon. Health minus equals owner dot current statistics dot damage. So the tower that hit me, its current damage. Whenever we upgrade towers, the current statistics will increase. So we need to get the current statistics and then the damage of that. If health is less than or equal to 0, we need to remove it from the wave. Then we need to call die. We need to call session.singleton.addMoney. And we need to add it the same way we did above with the damage over time method. And we add it by checking if it is boss. We need to multiply the money per kill by the boss scalar. If it is not a boss, we just need to add money per kill. Okay, and just like above, if die event does not equal to null, we need to call die event this, comma, event args.empty. Okay, so that is all wrapped up in an if block, so let's create an else block. For hit timer is equal to 0.4f, a little bit longer than the damage over time hit timer. So the hit timer is 0.4f, and we need to set hit display is equal to new text, opening parentheses, owner dot current statistics dot damage dot toString, comma, and we need to add the new vectors just like we did before, a new vector object for our location that we want it to be and our velocity. So new vector2 rectangle.right plus 3, comma, rectangle.top, closing parentheses, comma, new vector2, opening parentheses, velocity.x, comma, minus speed, closing parentheses, and semicolon. Alright, last method for the monster class, and then that we can put this class behind us. Okay, if the monster is in a delay state, we don't really need to draw the monster at all, because it should be behind the spawn or destination tile. And those are above the monster. You see our spawn house and our destination house. The graphics are above our monster. So we do not really need to draw our monster if it is in a delay state. So I'm going to wrap the entire method in an if block, which basically is just this one line here. So if delay is less than or equal to 0, I'm going to wrap the base.draw line in this block. Now above it, I'm going to do more coding. I need to create a texture 2D reference to the texture we have. Texture 2D T is equal to texture. If hit timer is greater than 0, we need to change texture is equal to hit texture. We hit the monster, we need to display the hit texture. We call base.draw after that, and then after that line of code, if hit timer is greater than 0 and hit display does not equal to null, hit display.draw, opening parentheses, sprite batch, comma, session.singleton.ui.font, comma, session.singleton.map.forecolor, closing parentheses and semicolon. Now the last thing up for this class is to set the texture object back to the T reference we have here. Alright, so that is it for this method. We can go ahead and save it, and we're ready to go to the tower class. So stay tuned for the next tutorial, which will cover the tower class. Thanks, and I hope you enjoy this tutorial.